All right. Can you see? I'm going to get you guys back on screen. There we go. All right. So Neil gave you some background, but the real background is that I'm Australian, and I know I don't sound American, and I have been here for about 20 years. And I haven't picked up an American accent, and I get congratulated every time I go home to Australia. So it's funny. Anyway, these are some images that I just love, and this, can you see my pointer? Great. So this here is actually where I grew up. This is the beach near where I live, and this pool is where I learned to swim. And there's a lot of these rock pools on the coast of Australia, but particularly around Sydney, and they're very efficient. I mean, it's obviously seawater, but every time I go home, there's a big esplanade along here that I go and take a run and go and swim. And I have learned to surf. I did have one of these ideas that I've got to do something new and different every year. And so I did have a big surfboard. I can tell you about that another time. But anyway, these are some of my favorite animals as well. And this is Sydney. I'm from Sydney. And has anyone been to Sydney? No. Okay. That's a bummer. You guys lose. Okay, let's move on. So, so this is just a bit of background, because I always like to know who I'm talking, who's actually talking to me when we're giving a presentation. I'm always wondering about them. And yes, I'm from Sydney, the southern suburbs, which you saw. My original training is in education. I was in physical education, health and geography from the University of Sydney. And when I went through university, there was no such thing as exercise and sports sciences. That hadn't been invented. I think it was actually just starting up in the US. So you went through and did a Bachelor of Education. And I was a physical education for a few years in Downlands College, Queensland, as well as a geography teacher, which I just loved. But ended up getting out of it and going back and doing what we call a postgrad diploma, sort of like a master's at the University of Wollongong, which is just south of Sydney, and then a PhD, because I wanted to stay in education, and I really do love teaching, and I have that degree. This is a picture of me when I'm young. I don't know which is me, but I'm an identical twin, and you can probably see that. And my sister, who she's a physical therapist, interestingly enough, and we speak almost every day. But that's a whole other story as well. There's a reason we speak every day. We've sort of got this side business. Anyway, I'm from Australia. Australia has 25 million people. That's not that many. I think when I was growing up, it was about 15 million. And so I come from Sydney. It's in the southern hemisphere. And yes, it is a long way, but it's about a 15-hour flight from LA to Sydney. And so I did my PhD, and at the time that I did my PhD, most of the universities in Sydney and Australia, they're not privately funded like Marquette. They are state funded or federally funded. And the federal government at the time in the early mid-90s, mid to late 90s, just gutted some of the funding to the education. And so there were no positions. And so I went and did a postdoc in Boulder, Colorado. Little did I know that Boulder, Colorado was just a fantastic place to land in America as my first place to live. And I had no ties. And so I came over here what I thought was going to be for a year. The fellow who employed me, a professor at the University of Colorado, truly a wonderful mentor, Roger Anoka, and he is very well known in the area of biomechanics and the neural control of movement. And he was at he had a lot of federal funding at the University of Colorado. And I said, well, I'd like to come for 1 year. And he said, no, 3. Because I didn't realize at the time when you go to do a postdoctoral fellowship, which is like the research that you do after your PhD before you become a faculty member, that it's sort of like the honeymoon period. You don't have any of the administrative responsibilities of that's associated with being a faculty member. You don't have to teach. You just can do research, and you can really launch yourself as an independent investigator. So I was there for 3 years, and it takes at least 3 years to have a very meaningful experience. And so I went there, and with my bike and with 2 suitcases, landed in Colorado, and I have never gone back to Australia to live. I go back about once a year, but I never have gone back to live permanently. I did end up, I was there in Colorado for 4 years and had just a fabulous time. Just in a research environment where there are a lot of people, where he was an excellent mentor, and he provided structure to research. And I learned a lot. And even though I had done a lot of really good research in my PhD, it's really the postdoc that helped me understand how to do it well, how to write grants, how to write papers well, how to mentor junior people underneath me, like PhD students and master's students. It was almost like a place to practice that, but yet with the mentorship of someone like Roger. And that's where I really found my wings. And I also got married. And so to an American who likes to think he's Australian and tries to put on the Australian accent, not very well, by the way, but I won't tell him that. And so we then moved after about 4 years, and he's actually, by the way, he's Texan. So, but he doesn't sound Texan. And then we moved to Marquette, well, not Marquette, Michigan, but Marquette University, and in Wisconsin, where I've stayed. And honestly, I didn't think I'd be here this long. Marquette's been a wonderful place to put roots and to have a child and grow a family. So, and I came in 2003, and so that's 18 years. Wow, that's gone really quick. And really, Marquette's been a wonderful place to establish a career. So that's part of my story. So at the moment, I'm a professor. I became a full professor in 2014. As Neil mentioned, I'm director of the Athletic and Human Performance Research Centre. I'm also a fellow of the American College of Sports Medicine. And I'm also an associate editor of 2 journals. They're 2 of the top journals in the field, which I work, Medicine and Science in Sports and Exercise, and Exercise and Sports Science Reviews. And that's really interesting because you get to be a bit of a gatekeeper to what gets published, and you learn a lot, some of which I'm going to tell you about today. And as Neil mentioned, I'm also chair of the steering committee of the Marquette COVID-19 Research Initiative, which started last year, the pandemic. Now, since being at Marquette, I've been able to establish some funding through the National Institute of Aging. So a lot of my work is in the National Institute of Aging, and I've been continuously funded all this time. Some of you students won't understand the relevance of these numbers here, but AG means it's the Institute of Aging, which is an institute within the Institutes of Health. And so I do a lot of aging research. And that's a smaller grant, that's a slightly bigger grant, and I got 2 of those in a row, but you can see it's continuous. And then another bigger grant, and then finally I got an R01, which is one of the larger grants, and that has just been renewed. So that's been a really nice progression over the last 18 years since I've been here. I've also had some other funding, some non-federal funding, and I highlight, this is one of my, I've got some CTSI funding at the moment through MCW and Marquette, where one of my students is looking at Achilles tendinopathy. But I highlight this because it was the first grant that I ever got, and it was through the American College of Sports Medicine, and it was only for $10,000. And this latest one is for $3 million. But this $10,000 grant was by far the most happiest I think I've ever been. I was so elated because I got a grant and I was successful, and I'd never been in that realm before. And even though it was a smidgen of what we're getting now and the funding that I have now, it was very, very meaningful. And it was also meaningful because it was the first work that I did on sex differences in fatigue, which I'm going to tell you about. So the research areas that I'm involved with is aging, and you can see from the funding mechanisms. I look at athletic performance, but fatigability and why older adults are more fatigable than young adults in their limb muscles. And I'm going to expose you to some of that. And then, can exercise training be protective against that? Because as you know, our population is graying. It's getting a lot older on average. And so we have got this huge problem that's starting to arise in the healthcare system, where a lot of the people are getting older, and older people, particularly 65 years and over, are the biggest users of the healthcare systems. And so they're starting to drain the health systems. This is not just in the USA, it's in Australia, it's in Europe. And so this aging, graying population is just becoming a huge issue. So there's a lot of money being put behind it. So the more that we can keep people out of hospital, and the more we can keep them independent and out of nursing homes and all that dependent care, which is very, very expensive, then the more healthcare costs we can save, and it's just going to be a better solution in the end. I also do some work on diabetes. I have a graduate student continuing that work at the moment. And just in the last year, COVID-19, who would have thought, if you told me 2 years ago, you're going to be doing all these studies and getting all this funding for COVID-19 and looking at the persistent and long-lasting effects on physical function, I would have said, what are you talking about? What is COVID-19? So, but here we are, and we have taken the opportunity and seized it. And that's probably another conversation, because just to tell you, a paper that we got published last year where I took some undergrads like yourselves, and David was in this group, where we deployed out to the supermarkets, asked the question, who is wearing a mask? We did 10,000 observations, sitting in cars, looking at people, male, female, old, young, and 10,000 observations. That study got published. There's 6 undergrads on it. Oh, no, 5 undergrads and I think a graduate student, 2 faculty. That paper since October has been viewed online almost 24,000 times. 24,000 times. It has been downloaded as an article at least 3,500 times. And it has been cited, I looked last night, 59 times. Now, none of my other papers do anywhere near that. So it was just being opportunistic, seeing where the gaps are and going with it. And David was a part of that. But what I'm going to talk to you about today is the sex differences, because it's a really interesting story, and the sex biases that are within the medical system, within the academic system, and just within life and athletics. And these are some other areas that that I've had grad students look into. There's Achilles tendinopathy, postpartum muscle function. That means women who've had babies, and looking at abdominal function. That's a whole other story. Boy, I could go on about that. And then there's, the effects of stress on muscle function. So I've covered a lot of things in the last 18 years, but I love it all. But what I'm going to tell you about today is performance fatigability, and that's where a lot of my funding is around. So what do you mean by performance fatigability, Dr. Hunter? What does that mean? It means that decline in an objective measure of motor performance over time. So it's different to fatigue that might be associated with disease such as multiple sclerosis or cancer after radiation or chemotherapy. That sort of fatigue, which is often doctors see as clinical fatigue, which is above and beyond what you'd expect for a given activity. This is what we study is different to that. It's exercise-induced. It occurs, it's acute and it's reversible. It occurs during maximal and submaximal tasks. And I'll give you some examples. It could be that decline in running or walking speed over time or distance. It could be the cycling power speed and the decline that occurs during a time trial. Or it could be just the reductions in force, velocity, and power during single limb exercise. Now, these are all expected. If you walk up some stairs, for instance, and we measured your muscle function before and after, multiple stairs, we'd expect you to be fatigued and maybe the force to be less. That's expected. You'll recover and it's reversible. That's what I study. Now, when we talk, before I define it even further, why would I care about muscle fatigue or fatigability? I'm going to tell you why, because I think it's a basis of rehabilitation. But when we think about fatigue, we think about negative aspects of it. Okay, fatigue of limb muscles, that contributes to loss of function. You know, you lose force. It occurs during athletic performance, but it also occurs ergonomically. So when you're standing, might get postural fatigue or fatigue within your upper arm here, which leads to injury, or lower arm, I mean. It occurs during daily activities, and it occurs during aging and disease and in clinical populations. And as I suggested before, it also contributes to injury and work-related neuromuscular disorders in men and women. So there's those negative aspects to it, but fatigue is also very important because it contributes to neuromuscular overload and adaptation, which is absolutely necessary for effective rehabilitation and training. For instance, if you go to the gym or to the physical therapist and they ask you to do some fatiguing exercise, there's a reason for it. They want to overload your system so that with adequate recovery, it adjusts and it either increases in strength or muscle mass. It's absolutely necessary. And so it's understanding fatigue and how it works and why it works and how it occurs and how it occurs during different tasks is really important for rehabilitation. And here's another thing. It also contributes to decreased pain after exercise. Now, our world often gives people a pill to negate pain, but exercise is a very, very powerful non-pharmaceutical version of and strategy to combat pain, and there's a lot of work yet to be done in this area. Okay, so when we're talking about fatigability, in the lab, in the laboratory setting, this is a definition of it again, an acute, so it's reversible, exercise-induced or activity-induced reduction in the expected force or power of a muscle. And we can measure that in my lab or any other lab as in devices like this. Here we have a force transducer. We have someone sitting in connected to the force transducer, and we've asked them to pull up with their elbow flexor muscle, so there's a force in the vertical direction, and we can ask them to do certain tasks. And this is one of them. This is the force record of this person here, this female, performing a task where we've given them a line at a target force at 50% of their maximum strength. And we've asked them to perform this task at 50% for 6 seconds on, 4 seconds rest, 6 seconds on, 4 seconds rest, until failure. And every minute we've asked them to perform a maximal voluntary contraction force, maximal strength. And we can quantify fatigue in two different ways. We can quantify it as the time to failure of this task. And so when they're not able to hold that 50% force task anymore, we can say, okay, that's their time to failure, and we can quantify that in seconds or minutes. We can also quantify fatigability by looking at the maximal capacity to generate force. And we did that. We asked them to do that by doing these maximal voluntary contractions. Now you can see the interesting thing is that while the person is able to perform the task successfully, their maximal force generating capacity is declining. So this is sort of like akin to running a marathon or going up some stairs. You can still go at the same speed, but gradually you're getting more and more fatigued, because if we measured your maximal force, it would be less. And eventually, if you kept going, it would get to the point where the requirements of the task are actually the maximal, is your maximal effort. So that's how we measure fatigue in the lab. And while the force output occurs ultimately in the muscle, here we have a brain, spinal cord, and the muscle, and in sets of up close versions of what's going on in the muscle, that ultimately the force occurs at the muscle. We all get that, okay? But where does fatigue actually originate? Is it from the muscle, or is it from inability to activate that muscle? And that's one of the questions that we have with aging, with sex differences, with clinical populations, people with diabetes. Where is the site of fatigue? Is it within the central nervous system, or is it within the muscle itself? Now, multiple mechanisms can contribute to these reductions in force, and that's because there's feedback from the muscle. If you start to have a buildup of lactic acid and some of the hydrogen ions that occur as a result of contraction, it sends signals back via the afferents and causes inhibition within the spinal cord and within the brain, and causes less action potentials to come to propagate down. So it's tricky. It's hard to understand where the site of fatigue is occurring when there's multiple systems changing. But that's one of the things that I do in my lab, is to try and understand that. And we do that by stimulating the muscle, stimulating the brain, while people are performing these contractions, whether they be dynamic. So this is the setup for the elbow flexor muscles, and we stimulate the nerve and the muscle. We can also, and in this contraption, the person can move this way, forward and back, and we can measure, here's a motor, this is a big force transducer, a dynamometer, and we can measure the amount of force, the velocity. We measure the electrical activity of the muscle with electromyography, and we can stimulate the muscle independent of the central nervous system, so we can understand the behavior of the muscle independent of them activating anything. And so as a result of that, we can understand, where's the fatigue occurring during a voluntary task? Is it purely because of fatigue within the muscle, or is there some sort of inability to activate the muscle? And we've got all these techniques to do this. This shows the elbow flexor muscle setup. This shows the knee extensor setup, which are the quadriceps. You can see we've got electrodes over here where we can stimulate the muscle. We also stimulate the femoral nerve. And we also can stimulate the brain, and where we can find out the integrity. We can measure electromyography signals down here at the muscle, and we can understand the integrity of the action potentials, and whether they're firing at the same rates. There's a whole host of techniques that we can do to try and understand other knee extensor and what's going on in the central nervous system. We also have setups for the first dorsal interosseous, which is this little muscle here, and also the ankle plantar flexors, which as well as dorsiflexors. All right, so that's just giving you an introduction. Some of the other things we do, we do muscle biopsies, because what we're really interested in is, okay, that's the whole limb setup that I just showed you, but we can also try and understand what's going on in the muscle by extracting fibers, muscle fibers. You can see here Chris Sundberg, who's now on faculty in the exercise science department, and myself. We can do muscle biopsies, and these are some of the bits of muscle that we pull out, and we can perform experiments on them by, I don't personally do these, the students do, particularly in Chris's lab, and Dr. Bob Fitz, who I've collaborated with for many years now. But we can hook these up to very small transducers, get the little single fibers out, and see what their force generating capacity is, do experiments on all the proteins, see what the fiber types are. There's a host of experiments. And in fact, now what we're doing is we're doing muscle biopsies and also extracting some of the arterioles that we extract from the muscle, from the skeletal muscle, and we now have a setup where we can look at the vasculature and how it reacts to being to all sorts of different chemicals, and understanding how it dilates and how it shrinks under different circumstances. And we're looking at those people with diabetes as well as aging. So that gives you some ideas. So what I'm going to go on for the last half of what I want to talk about today is the sex differences in performance, because I think this is really, really important, and to expose. And I never intended to start my research off in sex differences. It's just, I say to people who ask about it that if there's a big hole, a gaping hole in the literature, or let's say in the ground, I'm curious and I go over it and look in the hole and see what's there. And guess what? I keep falling in it. And by far, even though all of my work, most of my work has been funded through the National Institute of Aging, I can tell you now I'm much known, better known for my sex differences work internationally. The first real international invitation I got to as a keynote to the European College of Sports Science in the Netherlands was on sex differences. The second one that I got invited to the next year in London for the Physiological Society there was on sex differences. It just I keep getting asked to talk about this because I believe because there's a huge hole and there's a huge gap, and I just happen to keep looking in and seeing what needs to be done. So we know that every cell has a sex. Okay, just take that in. Every cell in our body has a sex. And these sex differences, these potential sex differences in gene expression can occur in every cell. Therefore, there's implications. As a result, and that's because of the chromosomes, so the different chromosome setup, okay? So for males and females. As a result, males have larger hearts, they have more hemoglobin, they have less body fat, they have more muscle mass and larger fiber sizes, and they have a larger percent area of fast fibers. Now, that's just a smidgen of the sex differences that occur between males and females. But I'm talking about these in particular because it leads to differences and sex differences in performance. That's why males are stronger and they're quicker. And as a result, strength times speed equals power. And power, muscle power, is highly correlated with our ability to get out of a chair, go upstairs, do activities, throw a shovel around. And that may not be such a problem when you're young because there's a big buffer between what it takes to do those activities versus your strength or power, but it has very large implications when you're older and you've got weaker and slower. Now, interestingly, although males are stronger and faster, they're also more fatigable. I'm going to talk about this, and this was a hole that I fell into. But before I go on to that little interesting piece of information, because of these physiological and anatomical differences between males and females, there's large sex differences in exercise performance in absolute terms. So if you look at world records, okay, that might give us a hint as to any sex differences in physiology independent of motivation and training, which typically don't differ between the sexes. Now, I couldn't have said this statement a century ago because women weren't allowed to train. Women weren't even allowed to run the marathon. I'm going to talk about that. They weren't allowed to go in some athletic events. It just wasn't socially acceptable and it was illegal. But if we look at the world records today, if you look at the marathon, both Kenyans, it's around about 10% difference. So you could probably say, okay, there's probably a sex difference in physiology and anatomy that is about 10%. If we've got people who are well-trained, equally well-trained and equally motivated, which males and females typically are at the very top in marathon. And if you look at the world records in some running, jumping, swimming events, it does vary. You look at non-weight bearing differences in some of these longer events, it's much smaller than some of the other events like long jump, where a lot more muscle strength and power is required. But there are these sex differences where the best male will always outperform the best female in the world. Okay, now fatigue of limb muscles can really define the limits of performance in males and females. I'm not talking about the cardiovascular system, but certainly in the neuromuscular system it can. And so that's something that I've been looking at. And so, you know, we might sort of think, well, this is simple. Sex differences in exercise performance around about 10% or 12% if we look at world records. Game over. We're fine about that. But it's actually our understanding of the magnitude and the cause is not so simple and straightforward. And I'm going to walk you through this. Here's a really interesting paper that was published in 1992. It caused a bit of a ruckus because just look at this. This was a statistical approach asking whether women will outrun men soon. This was published in 1992. And what these academics did is they graphed or they plotted the world records and this is the mean running velocity in meters per minute, the world records of males and females for the marathon, 1500, 800, 400, and 200 meter events. And then they took the trajectories. And if you notice that in each case, the females have a much steeper improvement and trajectory. And so they said, well goodness, if we just take the regression and we take it out to the intercept, of course, women by 1998 will outrun men in 2 hours, 1 minute and 59 seconds. You're probably thinking already, well, that's problematic. And it is problematic because it doesn't recognize this statistical approach, ignores that there's sex differences in physiology, ignores that the historical and sociological factors have contributed to these steeper increases in performance and improvements for the women versus the men. Now, they were doing this as a bit of a tongue-in-cheek, but they were making a point. And so it's not so simple. And there's historical and sociological factors that are lasting and continue today. I'm just going to highlight a few. If you look at the participation in sport and activity, it's much less among females than males. If you look at any of the CDC, any of the data that looks at physical activity of males and females, males always report that they are more active than females. So you've got to ask why. Are the guys lying? Are the women underestimating? Or is it true? Well, I actually think it's true. And certainly people do always overestimate how much activity they do in a questionnaire. But typically it's not different between males and females. Now, what this leads to is a lack of opportunity, facilities and messaging that female participation is less valued. And that happens overtly and subtly. Do you remember about a month ago, maybe 2 months ago now, the NCAA women's basketball and the facilities for the tournament? And the women got a small stack of weights and a few yoga mats, while the men got a palatial room of equipment for the NCAA basketball championships and March Madness. That was shocking, but it wasn't surprising. It wasn't surprising. It's very sad, but it wasn't surprising. The consequence is, and I'm going to show you some data, that the sex differences in performance, even at the elite level, are much greater than we'd expect physiologically. Also, exercise and sports science studies, both past and present, typically involve males, and I know this because I'm an editor, or a lack of distinction between males and females. And biomedical research in general, that is rampant. If you ask many of the people who do research even in BISC, in biomedical sciences, a lot of their animals are males. So a lot of what we know about the human body is often about the 70-kilogram man. And there's a reason for that. And a lot of medical information of physiology was based on that up until, I think they're changing it now, but the 70-kilogram man, assuming that that's relevant to females and that it's relevant to obese people, people of color, the white man, I mean, people of color, and minorities in general. And we know that that's not true. So, like I said, the assumption is that males and females respond similarly to exercise and to interventions, which they don't. And I'm going to show you that women are less fatigable than males. Now, here's a progression of some of the females in how research in biomedical research has progressed over the last few years. In 1993, there was the inclusion of women, which was mandated in any National Institute of Health funded studies with humans. And the reason it was mandated is because it wasn't happening. A lot of the research was on males only. And that's because they were the ones in the labs doing the research and available to be subjects. It wasn't until 2001 that the Institute of Medicine report called Exploring the Biological Contributions of Sex concluded that sex matters in all aspects of cellular function and physiology from womb to tomb. That isn't that long ago. And it wasn't until 2014 that NIH required sex and gender inclusion plans in clinical research using cells and animals. And it wasn't until 2015 that sex was considered a biological variable. And that's because it wasn't happening, that a lot of the research was being done on males only. And so it wasn't surprising that it wasn't until 2001 that the first review on sex differences in human skeletal muscle fatigue was published. And that's when I first started coming into the field. And so the approach I've taken to this area is to look at performance fatigability with laboratory-based experiments, sort of similar to what I've shown you before. And that's where we do laboratory-based experiments. We bring people into the lab to try and understand the differences between males and females. And then to say, okay, out in the real world, this is probably what's happening, okay, to make those inferences out in the real world. The other approach is to take real world performances, data mining, big data, which we can do now because we've got all this online data, and to determine if what we see in the lab matches with what we see out in the real world. Now, often it doesn't. So I fell into this area and I started looking at the marathon. Now, this was never my intention to start looking at this. I was always a lab-based experimenter. But remember my background as a a physical education teacher. So I've been out there in the real world doing this stuff. So, and you can imagine that in the laboratory-based experiments, that sex-related differences along this neuromuscular system, whether it occurs in the muscle or if there's sex-based differences in the brain and the spinal cord, will lead to differences in both the cause and the magnitude of fatigability in both young and old males and females. So what I'm going to do is just breeze through very quickly some of the experiments that we did. This was one of the first experiments I did in the lab, where we exposed these huge sex differences, where women are less fatigable than males, and therefore they may be under prescribed in the PT clinic with exercise. We did this experiment where we asked women and males to perform a contraction at 20% of their maximum. Now, the males were a lot stronger than the females, but it was still at the same relative intensity. We found that the women were able to outperform the men by over double. It was crazy. I didn't expect this. It's all at 20% of their maximum. Now, as a result of that, many studies have been done. That was a hallmark study, and that's probably one of my most cited studies ever. It actually started off as a reliability study, by the way. We just happened to come across these huge sex differences, which I didn't expect. I didn't even know existed. And this graph here summarizes some of the sex differences in fatigue. These are all individual studies. Over 55 studies is represented here. But the whole idea here is any data point above the line, it's relative to the force that was being performed at, whether it be 20% of their maximum or 50 or 100%. For any of these different muscle groups, most of the data points are above the line. So what that means, most of the literature here is saying that women are more fatigue resistant than men in all these contractions. It's crazy. So think about that. If you're prescribed a contraction in PT when you're doing physical therapy, and 8 contractions or 10 contractions, whether you're male or female, as a female, you may be being underprescribed because you're not fatiguing enough, because you're less fatigable. Anyway, so there's some of the implications. I ended up developing a model, and I'm not going to take you through it, but as to why the physiological mechanisms that may be contributing to why women are less fatigable. And it makes sense, and I've devoted about 15 years to trying to understand, is it coming from the brain? Is it coming from the muscle? The bottom line is it's coming from the muscle. Women and males and females have equal ability to activate their brains and to activate the muscle from the brains. Neural drive is similar. It's the muscle type. Women have more fatigue-resistant muscle. They might have less force, but they have more fatigue-resistant. If we go to the dynamic contractions, now they're all static contractions, okay? If you go to dynamic contractions, it starts to change a bit. This is a contraction where we got males and females to perform very controlled dynamic contractions through a range of motion with the elbow flexor muscles as well as the knee extensor muscles. And we asked them to perform 90 contractions through a 90-degree range of motion with a weight at 20%. And we looked at their drop in velocity, how much they slowed, and therefore the power. This is what we found. In contrast to some of those static contractions, the males and the females decreased very similarly. And in fact, what you find is that the faster the contraction, this is speed here, and this is the sex difference in fatigability between males and females for the elbow flexor muscles. The faster, the less the sex difference. And it's only at these slow moving and static contractions that we see these large sex differences. Very interesting. Has lots of implications. So what I'm going to end up, that's some of the data that I perform in the lab. I'm just going to end with some really interesting data on the marathon, okay? And it was back in 2008 that I was rung up by a reporter from Runner's World. Do you guys know that magazine, Runner's World? Some of you may have heard of it. And the female who won the Olympic marathon was 38 years of age, and the male was 21. And the reporter asked me, do men and women differ in the age at which they peak in their marathon performance? In other words, are women older when they peak in their marathon performance? And I said to her, I have no idea. But I've got a bunch of undergrads in the lab, and we will find out. So what we did is we went back to the online records, and we just looked at performances, and we looked at the age of when they won. And this is what, and it got published in Runner's World. They wrote it up, but these are the results. We ended up publishing the data. It got a lot of press. To cut to the chase, we found that both males and females were 29 years of age when they won the marathon at the elite level. This shows different marathons: Berlin, Chicago, London, New York, Olympics, and it looks like there's a bit of a difference here, which there is, that the women were older for these flatter marathons, but on average, they were the same, 29 years of age, and the range of the winners is the same. It's somewhere between 20 and 40 years of age, which is really incredible. But there's no sex difference. It was just happen chance. It was anecdotal. Okay, but what we did, and this is where it really took off, this whole slew of publications, we found there were no age differences, but we started to look at the data and the sex differences in performance. Now, remember, I said that the sex difference in performance of the world records around about 10%. So you'd expect, if you compared some of these elite marathoners, even up at the, say, 5th place, they might be about 10%. Well, no. So there's history behind this. And that's because before 1970s, women were not allowed to run the marathon. This just blows my mind. It was illegal. And this was a series of photos in the Boston Globe from the 1967 Boston Marathon. This woman here, Catherine Switzer, who's still alive today and gives talks, she was a university student at the time from Syracuse, and she entered as Kay Switzer. This is the race director here, trying to push her off the course. and it was captured on film and put in the Boston Globe front page. Well, boy, did people go wild. Did the women go wild? And if we look, and as a result, by 1972, women were allowed to run the Boston Marathon, and it was legal across the world. But look what happens. This is the world record for females and males. This is a 2-hour barrier. And the world record decreased as more women competed. It just plummeted because suddenly you're getting a good talent pool of women who are probably going to be the best physiologically. This is when Title IX occurred. This allowed equal opportunity for females educationally. Now, remember that up until then, all the athletic scholarships went to guys. I mean, women weren't allowed to be on rowing teams, but with the Title IX, it said, if you're a university, you could have equal opportunity for females and males, which is why now women have been had the fortune, the equal rights to education, but also scholarships. It wasn't until 1983 that women were allowed to run the World Championships and Olympics, and I was young enough to see that for the first time. It was heartening. So what contributes to these sex differences in marathon? Is it purely physiology? No, it's historical factors too, and I'm going to show you one example of that. I'm not going to go through this just for lack of time, but just to tell you that there's many things that contribute to sex differences in the physiology between males and females and running, but it's mostly around what we call maximum oxygen uptake, and which is about a 10% difference between males and females. And it's because men have larger hearts, less hemoglobin, and less body fat than females. That allows them to perform more quickly than females over these distances. And also there's racial inequities as well. Kenyans absolutely dominate the marathon in the males, in men. And this is some data that I looked at in the emergence of females in the top 50 since 1980 up to 2013. And you can see that the women there's about a 10-year lag, but now women are now able to, there's a lot more women who are competing who are Kenyans. And in 1914, there was only about 48% of the top 50 marathon runners in the world were female, when 98% were male. In 2021, women are up to 75%. So it's not surprising that now, for the first time, the female record holder is a Kenyan, and that has, and they're just genetically predisposed to having really good running times. I'm just going to end on, is this sex difference, what is it, 10% across the board? No, it's actually not. In fact, when we went back to that data, when we looked at all those marathons, those, the Berlin, Boston, this is really interesting what we found. We found that if you compared first place, it's around about 10%, 11%, which is what you'd expect based on what we know physiologically. By fifth place, these are the fifth best place runners in the world in these highly elite marathons, it had blown out to 12%. Why? We expected this to be flat. And we hypothesized at the time it's depth of running. Women just haven't had the chance. Participation levels are less. So, and this is the last set of data I'm going to show you. So what we did to try and see, okay, how much is it that participation contributes to these larger sex differences than what we'd expect? So we took the New York Marathon. Now, the New York Marathon in 1980, now remember, now women are allowed to run the marathon for the first time ever. It's only been for about 10 years. There were 31,500 runners. But go here, this is the ratio of men to women. This means that for every 7 males, there's 1 female. So in 1980, there was about 7 males for every female of those 31,000. It has plummeted over the years as more women have been engaged and become more active in the marathon. In 2019, which was the last time it was run, is a ratio of 1 to 1.36. We're still not equal, okay, regardless. So what we did is we took 10-year age brackets, because Remember, the older women who are about 70, when they were young, they weren't even allowed to run the marathon. So it's probably less likely to have older women running. So what we did is we took 10-year age brackets, we took their performance, the sex difference of performance between first place in each of these 10-year age brackets, and between 20 and 79 years of age. And we also looked at the ratio of males to females in that group. This is what we found. This blows my mind, okay? If you remember nothing about today, remember this. We found an amazing correlation between the ratio of males, so the participation levels, and the sex difference in speed. Now, this here is, YX was MX plus B, the linear regression. If you had a 1-to-1 ratio, and you put that in here, a 1-to-1 ratio in this, you'd get around about a 10% difference, just 11% difference, which is what you'd expect physiologically. However, this data point out here means that for that 10-year age bracket, there are about 24 males for every 1 female. And that's what the sex difference is, about 30%. And so that makes sense, because it's not like you'd expect the talent pool isn't there for the females. And so what we found, if you take the average of all this data, it's about 17% for first place finishers. If you take the 11.4%, which is what can be explained physiologically, that's 2/3 of the data. The other 5.5%, which is the other third, is completely explained by participation levels. So here's my point. If we are not involving females in athletic performance, we don't really know what the sex difference is, because we haven't got the talent pool. We haven't got representative data. And there's bigger implications here. And I'm just going to go through this data. What we did is we went through some big reviews on fatigue. We looked at the references, and we found out in those references how much of the data was from males and how much was from female subjects. Guess what? About 1/3 was females and about 2/3 was males. So disproportionate testing of males and females and the underreporting of sex effects can really mask our understanding of sex differences in fatigability and exercise performance, but in biomedical research in general. If we're not testing females, we don't know their reactions to drugs. If we're not testing them at the rates that we need to, and this goes not just for females, for people of colour, for minorities, we don't know. The assumption is that what's relevant to white males is relevant to females, is relevant to black, white, yellow, brown, whatever. We've got to be testing diversity and females. And so I think I'm going to end it there. That's just the end product. And that you can see that there's 2 approaches here, performance fatigability in the lab, but also this approach of looking at big data can really, really help us understand what we see in the lab, and is it really truly reflected in the real world. I'm going to end there because it's right on 6 o'clock. Thank you. I hope you're engaged and you understood it. It's certainly not where my research started, but like I said, there's just gaping holes. There's so much to do to understand how females react, let alone different races. Have you ever, who's lined up at the 100-meter line at the Olympics? Are they all white men and all white females? No, they're not. There's a reason. There's physiological differences within race. And we haven't explored those differences at all. There's just a wealth of information, medically, biomedically, athletically, in rehabilitation that we are yet to understand. And we can't assume that what's relevant to males is relevant to females. And I say this not because I think females are more important, but because they're just as important. And we should know, as should we know across race. So I love doing this work. I love involving students in it, because particularly some of this online stuff. One of the students that I have had this semester doing some independent study from BISC is exploring the authorship of males and females in some of these top journals. It's shocking. Very consistent. It's about a third female. Anyway, sometimes I get depressed and sometimes I get excited about it. Any questions, folks?
Any questions, fellows, for Dr. Hunter?
They just want to go home. Oh, they already are home. Turn off the camera. And I understand that. That's fine at 6 o'clock. But hopefully it gives you something to think about.
Yeah, I think
question, but just being a runner, I think this was super interesting and I really enjoyed it. So I might be emailing you with some questions later because I feel like I have too much to talk about right now.
Yeah, I mean, it's one of the studies that we've just done is on the Nike shoes, you know, the new Nike shoe, the super shoe, and that's just about to come out because all the first studies were done on men, of course, they were. And so we've found some sex differences that women may have a greater advantage. Now, is it just to do with weight? I mean, the shoe doesn't know that there's a different sex up there. You know, it's just like, it's probably something to do with weight. But, you know, they call it the 4% shoe. Well, it's 4% for white males in a lab. They get the advantage in the lab. But how about people who are heavier or female or lighter? We have no idea. Anyway, we just got a really exciting study out about that.
Yeah, so we have another question.
Yes, that's my hand. Thank you so much, Dr. Hunter, for the presentation. That's so informative. And of course, as a woman, I appreciate that women issues are being brought on the forefront for that representation. But I was also shocked that male, even when they are stronger, they are more fatigable. I thought women, by the virtue of their physiology and other social factors and biological, like childbearing, I thought maybe it would factor in. So it's a surprise.
Yeah, I mean, that's a whole nother talk. And I was nearly going to take all that out, but I thought, no, it's worth interesting. It's worth to, because that's where this all started for me. They are less fatigable when you're at the same relative intensity. And if you strength match males and females, females will still outdo males. It's quite stunning. And it's because of the muscle makeup. Males and females have the same amount of type 1 and type 2 fibers, you know, fast and slow fibers, skeletal fibers, but the males have bigger fast fibers. So overall, the composition of the muscle is faster and more powerful, and their muscle fibers are just bigger overall. So as a result, those fibers are more fatigable. So they might be stronger and more powerful, but they fatigue more quickly. And so that's one of the reasons. We also wonder if estrogen, or I think they call it estrogen here, has anything to do, and nitric oxide, particularly with and cardiovascular function, has anything to do with it, and blood flow. And that's actually where some of my research has gone at the moment. Thank you. You know what? I'm going to give you guys permission to just go home. Neil, what have you got else to say? Thank you for listening. I love talking about this.
Yeah, thank you very much. This was really enlightening talk. Can I ask you one thing? And you probably have seen that one in your research and through your 15 years of experience working. So what's the role of psychosocial element is playing in this spectrum? Because they are being deprived, they are being taken off from all these opportunities still happening, and especially if you are disadvantaged, you are colored, or even if you are white, if you are not having wealth or opportunity or exposure. So how that work out?
Yeah, did I stop sharing my screen, by the way?
Yep.
I did. Okay, so I didn't realize I still had it on. Yeah, I think it has a big effect, like opportunity. So you saw, I mean, I think this marathon data is a small window into a much bigger issue, that if you don't have the right representation, then you don't truly understand the true differences, whether it be physiological, anatomically, that exist. And I think the women, why are they not participating? Well, there's history there, okay? Overall, they were never even allowed to, so they're less valued. I mean, there's so many issues around this. I mean, I looked in the Sydney Morning Herald this morning, which is sometimes my go-to Australian paper, and on the front page was women are upset in the surfing competition because the men are paid double the women in their in prize money, and that is so normal, and the women are really mad because it sends a message: you are less valued, we don't care about you, so why would you even aspire to do activity? And it's the same deal within academia. If you don't, I mean, you guys know this more than anything, if you don't see females or people of colour at the top, the message is there is no place for you here. There is no opportunity for you to be in leadership or to aspire to be someone of influence. And so the psychosocial factors in so many different levels is just so important. And because why bother? I'm not going to be successful, so I'll try something that I can be successful at. And it just breaks my heart. And you guys know more than I do too, that you can have two papers, a paper that is a manuscript that's put in for publication, or a grant. You change the name from Sandra Hunter to John Adams. John Adams gets scored really well, Sandra Hunter does not. And heavens, if you had a strange name that might seem ethnic or whatever, and they've shown it over and over and over and over again. It's got nothing to do with the science. It's got nothing to do with the value of what is meant to be scored. It's got to do with, oh, they're more likely to be successful. So it's self-perpetuating. I get pretty mad about this because I've been a victim of it, as probably most of you have. And it upsets me that all the people coming behind. So, and we've got to lift up women. We've got to lift up the underprivileged. We've got to lift up minorities. We have to lift up the underrepresented. And yes, the pendulum may swing the other way, but it has to, because if we just go back to status quo rather than swing the other way, we've got to get the momentum. It's just like, okay, well, let's have, we'll have equal representation on the board in the room. And I've been in boards where, I mean, you know, like boards of trustees and that sort of thing. We'll have the token female or the token, you know, black person or whatever. And they'll have a voice. They don't have a voice. Just because people are there doesn't mean that they have a voice. Because their voice gets pushed aside. They're there physically, but they're not there in terms of representation and value. And this is the other thing that I've learned of late, is that often it's not intentional. Often it's not intentional. It's just the status quo. And people don't realize I have unconscious biases all the time. I've just got to catch myself. And so does everyone. And often these biases and pushing down voices are usually not intentional. So education is everything. I'll get off my soapbox.
Okay. Go ahead.
Can I ask a question? Yeah. first of all, Dr. Hunter, thank you for your presentation. I think from the start, when you told us your history, the path that you've taken, for me, that was really touching, you know. Probably you should give us maybe some wisdom on how we should maneuver through this process. We have young fellows who are going to be, who are researchers, and they're looking up to becoming someone like you, someone who has reached at a level of winning such high-level grants. Maybe you could give us some wisdom on what we should think about as we progress through this path. My second question, sorry, is about, you are researching sensitive issues. In a layman's language, some group may think that you are suggesting that one group is weaker than the other, or one group is stronger than the other. In a layman's language, someone who may not, you know, pay attention to the detail of the research. Have you had circumstances where there has been a pushback in maybe ethics approval or lots of scrutiny during the publication process?
Do you mean stronger as in physical strength, or is that what you're talking about?
In terms of fatigue, many men want to be seen as, you know, the other way around, and yet science is showing us.
Yeah, actually the first, I'll answer that question first. The first conference I went to in Seattle when I'd landed in Australia, I presented these sex differences data. You know, women outperform men, or women have longer endurance times than men. Yeah, there were lots of people around my poster. And there was some older gentlemen who came up and said, I don't believe your data. And they were pushing on the poster like this. And I said, I didn't make it up. I'm not making this up. Yeah, males are stronger. And actually last year, so what relevance does it have? Because that's some of the pushback I've got. Well, who cares? Yeah, who cares? That's actually, one of my colleagues said that when I first wrote that paper up. It's now my second most cited paper ever. And he said, well, who cares about this? And so making that relevant to the real world is really important. And it came home last year. So was it last year, the end of 2019, before everything went haywire? The Swedish TV came out and they'd heard about my research, and they were doing this reality show in Sweden, and it was run by a very well-respected, what do you call it, national TV. They've got like what we call in Australia the ABC, the Australian Broadcasting, like it'd be like NPR, but in TV world. And they did this experiment where they got males and females and partners, and they got them to run through these 8-week programs. Some jogged, some did strength training, and they had these battery of tests before and after. And each week, the entire country, there's only like 9 million people in Sweden, but the entire country would, go on TV and listen to what this was about. And they came over to the States and interviewed me at the AHPLC, because I was the world expert on sex differences in human performance. And they came over because they noted these sex differences, that some of the women were outperforming the men. And it was like, they had this one particular test where they do a wall squat, a squat on the wall until they fall over. And they've got this fantastic TV moment where they're all outside in this really picturesque place. And at the end of the 8 weeks, the males, it might have been at the beginning actually, I can't remember, they're all, the males and females, they're all against a post each, and the camera's screening around doing this panoramic thing. And all the guys, after, I can't remember how long they did the squats for, let's say after 5-10 minutes, had dropped to the ground. All the females were still there. And I thought, my research is right. I didn't make it up. So yes, there is some pushback, but there's also some clarity around it now because we've done the research. And we've also done the research to show that the faster the contraction, the sex differences dissipate. But a lot of it's relevant because a lot of the contractions that people get in rehabilitation are isometrically static contractions to begin with. So we're under-prescribing females. Anyway, so that's one thing. The question you asked to begin with, it's just gone from my mind. I started to write it down. What was the first one?
I think it's about simple words of wisdom to this group of people who are beginning their research. Yeah.
Here's what I can tell you. It's about perseverance. I'm not smarter than anyone else. It's the 80% rule, okay? You've got to be smart enough. If you've got a PhD or if you're at college or in this program, you're smart enough. But it's about perseverance. It's about perseverance in getting the grants. I'll give you a situation. Before I got my first R01, which is like the woo of NIH funding for individual investigators, a colleague of mine, I'd started at Marquette and he was down in Texas, and he put a grant in and he said, do you want to be on this? Because I had helped him put it together a bit. I said, no, I haven't. I don't feel like I should. Anyway, and I put him on my grant because we really nutted things out together. We both knew that my grant was a better grant. He said it. He said it before I did. He's got funded, mine did not. And he apologized to me. He said, I'm so sorry. Your grant was so much better. I said, I know it was. But is it being female? I don't know. But it happened a lot until I just kept persevering. In other words, unless you are swinging the bat, you're not going to hit the ball. If you stop swinging, you're never going to hit the ball. You've got to persevere. I'm going to give you another example. A high school student has reached out to me from a school on the south side, and she's in an underrepresented, in a minority group. And when I said, sure, come on, yes, you can come and do some, clinical hours and research, I didn't hear from her. It was like, did I say something wrong? And I thought, oh, she's intimidated. So I reached out to the principal there, and she said, yeah, she was totally intimidated. And I thought, oh, please reach out again. Don't let that stop you, that fear. Don't let that fear stop you just because it's an unusual place to be at. Don't let that, everyone's scared, okay? Anything new, you're always scared. It's just whether you step forward or not. And I would say step forward, because what I have seen in academia is that typically males in particular, but white males, they're already empowered. They will step forward. They will ask for what they need. Not always. This is a broad generalization. But they will, because it's okay for them to ask for the raise, for that piece of equipment, to be on that paper, to whatever. Females tend not to. Females tend to, I've got to have everything in order. I've got to be more qualified, because that's what they're used to having to put up with. Be brave, step forward, even before you think you should be asking. Just ask. It won't hurt. That would be my persevere and fight against your fear. Because the biggest thing is, the worst thing that you can do is be held to that. And you're actually going to you spend a lot more time being uncomfortable in the fear than having asked and stepping out. And thank goodness that's over. The worst thing that can happen is that they say no. But if you don't, you've already said no. You've chosen that yourself. So that would be my words of wisdom. And yes, it's scary. And I don't want to have this idea that white males are, because, David, you're one. I'm sorry, I married one. I love him dearly. But there is a position of privilege there that my husband doesn't know. I've been in rooms at MCW where I'm the most senior person in the room, and my postdoc is getting all the attention from the other male investigators, senior guys. They're talking to him. They're not talking to me. It's like, whoa, wait a minute. I'm about 20 years more senior than him. He may be a lot taller and bigger, but why aren't you talking to me? That just happened a few years ago. I was furious. So what do you do in that situation? Say, hey, I didn't do that. I might next time. That happens. It's subtle and it's very overt sometimes too. They don't even know they're doing it though. They don't. They'd be embarrassed that I would be talking about this if they knew. I'm sure. Step out and persevere. You will. People will say no, but if you don't, you're already saying no. Let's go and have some dinner or something.
Thank you so much, Dr. Hunter.
Oh, thank you. I'm glad this was recorded. I'm going to send it out to some of my other students.
So thank you very much, Sandra, and thank you very much everyone else for attending. I think a couple of them actually left because they have like other engagement. So hopefully we'll be meeting back again on next week, Friday, for the final presentation.